Hello students, welcome to engineering assignments. Now we are going to part 2 of solving the problems based on MLE. So we'll start with the next question. Suppose that data x1 till xn are independent and identically distributed drawn from an exponential distribution exp of lambda. Find the MLE for lambda. If you have seen the last video, the last question was based on tossing of the coin. It was basically a Bernoulli's distribution. But this question deals with exponential distribution. So students, as I told in the last video, we should know the probability density function or probability mass function of most of the distributions which are available. Okay, so here exponential distribution is provided, so you should know the probability density function, that is PDF of a exponential distribution. The probability density function for a exponential distribution is written as fx given lambda, which is equal to lambda e raised to minus lambda x when x is greater than or equal to 0, else it will be 0. So instead of this semicolon, in some of the textbook you can find fx, a vertical bar, lambda. Okay, both are the same thing, don't get confused. The probability density function fx given lambda is equal to lambda e raised to minus lambda x. Okay, now what is the first step in MLE? The first step to find out the maximum likelihood estimation is to find likelihood, which is represented as L. Okay, and this can be written as pi I is equal to 1 to n lambda e raised to minus lambda x of I, and this one is nothing but it shows the multiplication. So in the question itself it is told that the data ranges from x1 to xn. So it can be written like this, that is lambda e raised to minus lambda x1 then into lambda e raised to minus lambda x2 till lambda e raised to minus lambda xn. Okay, it can be written like this. So you can see that the lambda is common in all these terms. So you can take lambda raised to n outside. Okay, that I have done here. Then next thing is pi I is equal to 1 to n e raised to minus lambda xi. Fine. So understood how we got the likelihood L? So if you got the likelihood L, the next step in maximum likelihood estimation is to find the log likelihood. It is basically to remove this pi. What is this pi? This pi represents the multiplication, and multiplication is very tedious process. So you have to convert it into summation. For that we have to apply log on both the sides. So when it is applied log on both the sides, then it is called as log likelihood. So let us find out the log likelihood of this L. Now log L, or we can represent it as LL. So log likelihood. So we are applying log. We get log lambda raised to n plus log pi I is equal to 1 to n e raised to minus lambda xi. Okay. Now if you take the log, what you will get here? N log lambda. Now what about this term? You already know that log e raised to x is x. So you can write it like this. Now you try out this. It will be the summation, that is summation of I is equal to 1 to n minus lambda xi. So here what happens is that the sigma will be converted into summation. Fine. Which is equal to n log lambda minus the lambda will be common for x1 to xn. So you can take lambda outside. Then you can put sigma I is equal to 1 to n xi. So you have got log likelihood here. In the next step to find MLE, you have to find the derivative of log likelihood with respect to lambda, and you have to equate it to 0. Whenever you do differentiation on this part, you will get n by lambda, and this part you will get minus sigma is equal to 1 to n xi, and you have to equate it to 0. So let us do the simplification in this. So you will get n minus lambda sigma is equal to 1 to n, xi is equal to 0. Then what will be lambda then? N divided by sigma I is equal to 1 to n xi, and you can see that this is 1 by mean. This is reciprocal of the mean. Tell you in detail, that is, see, if you have data points from x1 to xn, then how to find out the mean x bar? X bar is equal to x1 plus x2 till xn, okay, divided by n. The same thing, reciprocal, is shown here. So how can you write that? That is 1 by x bar. Understood how I wrote this? So we can write finally the lambda MLE is equal to 1 by x bar. So you got the answer. This is the answer for this problem. One more question we will discuss in this video. See, suppose that x is a discrete random variable with the following probability mass function, where theta ranges from 0 to 1 is a parameter. The following 10 independent observations are as shown in the table, and they are taken from such a distribution 3 0 2 1 3 2 1 0 2 1, and what is the maximum likelihood estimate of theta. So let us check how we can do this. The first step in finding maximum likelihood estimation is finding the product of probability of the data points given in the question. So let us find the likelihood L. The L is equal to, we just have P, x is equal to 3 into P, x is equal to 0 into P, x is equal to 2 into P, x is equal to 1 into x is equal to 3 into P of x is equal to 2 into P of x is equal to 1 into P of x is equal to 0 into P of x is equal to 2 into P of x is equal to 1. Now, these all are getting multiplied, no? So, it is similar to pi I is equal to 1 to n P of xi given theta, right? So this can be written like this: P of x is equal to 0. How many times it has occurred? 1, 2, 2 times. So it can be written as square into P of x is equal to 1. How many times it has occurred? 1, 2, 3. Cube into P of x is equal to 2. That also has occurred 3 times into P of x is equal to 3, which has occurred 2 times. Now it is already told that when x is equal to 0, P of x is equal to 2 theta by 3. So we can replace this with 2 theta by 3. So that can be written as 2 theta by 3 the whole square into x is equal to 1. So what is the value when x is equal to 1? It is theta by 3. So you can write it as theta by 3 the whole cube into, similarly you can write the x is equal to 2 as 2 1 minus theta by 3 the whole cube into 1 minus theta by 3 the whole square. So you have got the likelihood. Next you have to find out the log likelihood, that is represented as ln. Now let us find out the log likelihood of this likelihood. So when you take the log, it will be like this: 2 log 2 theta by 3 plus 3 log theta by 3 plus 3 log 2 1 minus theta by 3 plus 2 log 1 minus theta by 3. So in the next step, to make it little bit easier, what we can do is we can split it. that you can write like this: 2 outside, log 2 by 3 plus log theta plus 3 log 1 by 3 plus log theta plus 3 log 2 by 3 plus log 1 minus theta plus 2 log 1 by 3 plus log 1 minus theta. Fine. So it's basically done to remove the constants. So you can write it like this: 2 log. So you can write it like this: 2 log 2 by 3 plus 2 log theta plus 3 log 1 by 3 plus 3 log theta plus 3 log 2 by 3 plus 3 log 1 minus theta plus 2 log 1 by 3 plus 2 log 1 minus theta. You can see that this is constant, this is constant, this is constant, this is constant. So our equation will become like this. The log likelihood is equal to the constant plus 2 log theta plus 3 log theta plus 3 log 1 minus theta plus 2 log 1 minus theta. Fine. So we can write it as c plus 5 log theta plus 5 log 1 minus theta. Okay, so we have reached till log likelihood. In the next step we have to do is you have to find out the derivative of this LL with respect to theta, and you have to equate it to 0. So let us check out. So after taking the derivative you will get 5 by theta minus 5 divided by 1 minus theta, which is equal to 0. Solve it, which is equal to 5 minus 5 theta minus 5 theta equal to 0. Now you find the value of theta, that will be your MLE. So therefore MLE is equal to 5 by 10, which is equal to 0.5, and this is your answer. So students, we have discussed 3 problems relating to MLE. So thank you students, thank you for watching my video.